Okay, picking up where we left off in the January 2019 exam with question number 13. So it says the function f of x equals a cosine bx plus c is plotted on the graph below. The graph shown below. What are the values of a, b, and c? I'm going to show you a couple ways to do this. First is the easiest way. So a, b, and c, we need to know what those represent. A stands for the amplitude. C is your midline. We also call that our vertical shift. And then B is the frequency. So I'm going to focus on the A and C first. Your midline is essentially what we call like the shift of your x-axis or your new x-axis. It is that line that is perfectly halfway through your curve. So this right here in the middle is your midline. So my midline is at y equals 3, which means that C is 3 for this example because C represents the midline. So what's nice about this example and looking at that real quick is that there's only two answers that have a C of 3, which means this and this are wrong, so choices 2 and 3 are out. Next, I'm going to look at the amplitude. The amplitude is the height from the midline above and below the midline. So this one went up 2 values, this went down 2 values, which means that that is my amplitude. So now I know that A is 2. So I already have my answer. This one says that A is 4, so choice 1 is going to have to be my amplitude. To actually find the values, that was like the shortcut way. The longer way, if you're not really super comfortable with doing it that way, is using the formulas. The formula for amplitude is the absolute value of y max minus y min over 2. And the y max is how high up the graph goes. So the graph goes up to 5, so that's going to be my max. And it goes down to 1, so that's going to be my min. When I plug that in, I get 5 minus 1 over 2. 5 minus 1 is 4. The absolute value of a positive 4 just stays positive 4. And when I divide that by 2, I get that A is 2 anyway. The formula for C is really similar. It's just plus. So it's y max plus y min over 2. Still the same number. So it's 5 plus a negative 1 over 2. Oh, sorry, 5 plus a positive 1. My bad. So 6 over 2 is going to be 3, and I get a C value of 3. So those are the two numbers that I just got when I did it using the graph with the midline and then going up and down 2. But if you're more comfortable with formulas, that way will work. Now with working with B, B comes from the formula, period equals 2 pi over B. You can use this formula to find the period, or you can use the formula to find B. It just depends what you're working on. For this example, it's asking me to figure out what B is. So if I'm solving for B, that means I have to plug in for the period. So we need to know what period means. Period is the length of one curve. So the length of one curve would start here. Your curve ends here. This that I'm highlighting is one cosine curve. And it goes from 0, right here, to this value. So that means that the period, or the length of one curve, is pi over 3. So in this formula right here, I'm going to plug in pi over 3 for the period and leave that equal to 2 pi over b. And now again, my goal is to solve for b. So when I have a fraction equal to a fraction, you're going to cross multiply it. So I get pi b equals 2 times 3 pi, it's just going to be 6 pi. And then I divide by pi to solve for b, so these will cancel, and I get b equals 6. So that's how you can double check this part of it if you want to make sure you have A, B, and C. We were able to eliminate the other 3 choices, but it might not happen like that on a future exam, so that would be how you would find the b value. And the next one, number 14, which equation represents the equation of a parabola with focus of negative 3, 3, and directrix of y equals 7. We've talked about this a lot in class. Every time you have a focus directrix example, it is beneficial to graph it. So that's what I'm going to do. And since it has a directrix of 7, I know I want the graph to go up quite high, so I'm going to make my x-axis down here, just kind of planning ahead. So 1, 2, 3, 4, 5, 6, 7, and I need to go left 3. So I'm going to plot the point and graph the line of the equation that is given to me for the directrix. So the point negative 3, 3 is right here. I'm going to label that F for focus. My directrix is at y equals 7, so that's going to be this line right here that goes through y equals 7. That is not neat at all. But yeah, we're just going to leave it. So this is my directrix at y equals 7, and my focus is at negative 3, 3. the more you label, the easier this is going to be. Okay, now sometimes you're gonna have a situation like we have right now where the directrix is above the focus. If that's the case, the vertex is still in the middle. The other situation you could have is the focus is above the directrix, but either way, the vertex is in the middle. So what I'm not given in this example is the vertex. That's the first thing I have to find, and it's always perfectly in the middle. So what I mean by that is, like, if this is 2, this distance is 2. If this distance is 3, this distance is 3. So we have to count how many values we have between the focus and the directrix to find out where the middle would be. Just a little side note, you guys do have a scrap piece of graph paper on the exam if you scroll all the way to the end. Scrap graph paper, so if it's easier for you to count these values, you could have plotted it on here, -3, 3, and then went up to 7. If that's easier for you, you can always use the scrap paper. However, it won't be scored. It's just additional paper for you to work with if you feel that you need a grid for something. So like I said, I was trying to find the value between here so I can find that vertex point. If this is at a y value of 3 and this one's at a y value of 7, halfway between 3 and 7 is going to be 5. So this is going to be at the point, still the x value of -3 because it's still going left 3, but it's going to be up 5, and this is my vertex. Now, to come up with the equation using focus and directrix, there is a formula for that. The formula for this is y equals plus or minus 1 over 4p times x minus h squared plus k. So that's what I'm going to have to plug into for this one, where h and k is the vertex, and p is the distance. I love when that happens. Perfect, perfect, perfect. I don't know why that happens, but I just love it every single time. Okay, this was -3, 3. Just bear with me for a second. Sorry, guys. This was at 7, which was the directrix. This was the focus, and we found that the vertex was at -3, 5. Okay. The formula is y equals plus or minus 1 over 4p times x minus h squared plus k. Okay, so here we go again. hk is the vertex. P is the distance between your focus and vertex, or in other words, your directrix and your vertex. Those are going to be the same. So this distance right here is P. So the distance between 3 and 5 is 2, so that means that P is 2. You can also check it up here. The distance between 5 and 7 is also 2. So that means P is 2. So when I go to plug that in, I'm going to have 1 over 4 times 2. Notice that P is on the bottom. So it's 1 over 4 times P on the bottom. And then that's x minus hk. My vertex is -3, 5. Oopsie. So in place of h, this one's kind of tricky. I have x minus, and then h is a -3. So this is going to become a plus in here. And then plus k is going to be plus 5 on the outside. So when I look at my equations, I have 2 that... No, I don't. I only have 1 equation that has a plus and a plus, so it's got to be choice 3. But to go over the rest of this, these ones have a negative and these have a positive. Sometimes you might have a couple that have this whole setup, but one of them's positive and one of them's negative. So we need to know which one it's going to be. And the whole idea is that your vertex your parabola hugs the focus. So the vertex is where the turning point of your parabola is, so it could either go this way or this way. Because the focus is underneath this one, your parabola is going to go this way. So going back over what I had drawn before, like this. This right here, because the parabola hugs the focus, would be a negative parabola. If you have a situation where the focus is above, it would be a positive parabola. So because this one, the focus was below, it was a negative parabola, which means I wanted a negative sign out in front, and that's why this is a negative here. I know I'm giving you a lot of details, but you never know what kind of question you're going to have, and every detail will help you. All right, so for the next one, what is the solution set of the equation? This is a fractional equation, so I need to multiply everything by the least common denominator. So first I have to figure out what my LCD is. Remember, the rule to come up with the LCD is to take a little bit of everything. So I'm going to take the x that's here, and then I notice that this and this are the same, which is great. That's just going to be part of my LCD. When I said the rule, I said I have to multiply all 3 fractions by the LCD. So this is going to be x times 3x plus 1. This one's x times 3x plus 1. and this one's x times 3x plus 1. I know it's annoying to write that, but it does help. So for this one, I'm going to cancel out this. This I cancel out the x, and for this I cancel out the 3x plus 1. What I want you guys to recognize right now is probably the most important reason that we multiply by the LCD. All of the denominators canceled. If all of your denominators don't cancel, you did not multiply by the correct LCD. You should not have any more fractions anymore. That's why we multiply by the LCD. So now I'm going to put it all together. What I have left in my first fraction is a 2 and an x, so that'll get me 2x. I'm going to bring down the equals. This is a 1 times 3x plus 1, but if you distribute a 1 through, it's just going to be 3x plus 1, so I'm just going to write that. I bring down the minus sign. A lot of people forget that, so be careful. And then I have a 6x times x, which is 6x squared. Okay, because I have an x squared and an x, I'm going to have to get this equal to 0, so I'm going to subtract the 2x over, and I'm also going to put it in standard form. So I have negative 6x squared plus an x plus 1 equals 0. So unfortunately, to factor this, I'm going to have to use AC because there's a number in front of my x squared. So I start by doing a times c, which is negative 6. So I need the numbers that multiply to negative 6 that add to the middle number, which is a 1. So that pair of numbers is going to be 2 and 3, and to add to a positive 1, I'm going to need that 2 to be negative. So when I set this up now with AC, I need to create 4 terms so I can do grouping. So the negative 6x squared comes down. I split up that plus 1x into a minus 2x plus 3x, and then I bring down the plus 1. I have 4 terms now, so I can do grouping. I group the first 2 together and the second 2 together, and now I need to GCF each group. So the GCF of my first group is going to be a negative 2x. You could take out a positive 2x, so it all kind of depends on what you prefer. I want to take a negative out so that I have a positive here now. So that'll be a positive 3x plus 1. And then I notice here that I have a 3x plus 1 already, so that means my GCF is just going to be 1, and I'll be left with that 3x plus 1, because these have to match. So once those match up, you know that you factored this correctly, so that's going to come down as 3x plus 1, and then I put my 2 GCFs together. I have a negative 2x plus 1, and now I am not done solving, but I'm done factoring, so I need to tee this up. So 3x plus 1 equals 0, negative 2x plus 1 equals 0. When I solve this one, I'd have to subtract the 1 and divide by 3, so it'd be negative 1/3. To solve this one, I subtract the 1 over, and I have negative 2x equals negative 1, and then I divide by the negative 2, and I get a positive 1/2. So my answers are positive 1/2 and negative 1/3. But when you have a fractional equation, it is one of those situations where you have to check it. So when you check these, you have to check them just in the denominators. The only rule is that you can't have a 0 in the denominator. So if I check negative 1/3 in this denominator, it is 3 times negative 1/3 plus 1. When I do 3 times negative 1/3, I get negative 1, and negative plus 1 is 0. So this answer actually rejects. And I'm going to try the 1/2. If I plug in 1/2 to all 3 of the denominators, they will not get me 0. 3 times 1/2 plus 1 is not 0. And if I plug in a 1/2 right here, it's just going to stay 1/2. So that means 1/2 does not reject. It's my only answer, which means my answer is multiple choice number 3. So if this was a part 2, you would need to know how to solve that step by step the entire way. Because this is a multiple choice and you have to check your answers anyway, here's where I'm going to give you that hint of a work smarter, not harder. You're given an equation. Let me just clear this all up real quick. You're given this equation and you're given 4 possible solution sets. You can just plug the solution sets in and see which ones work. So essentially you're just doing the checks. So I could have plugged in negative 1/3 into the entire equation to see if it works. It doesn't work, so that one would have been out. You plug in 1/2 and it does work, which is great, and that kind of gives you your answer right away. If negative 1/3 doesn't work, you would do this and this, but you would have to plug it into the whole equation if you don't go through all of the steps of solving it. All right. And now that we've done, 3 examples? Some of these take a little bit longer, especially when you get later in the multiple choice. They just start to take a long time, and that's okay. Don't panic if that happens to you. It is meant to happen sometimes. This next one is not too bad. So Savannah just got contact lenses. Her doctor said she can wear them 2 hours the first day and then increase the length of time by 30 minutes each day. If this pattern continues, which formula would not be appropriate to determine the length of time in either minutes or hours she could wear her contact lenses for the nth day? So for this, kind of tricky because of the situation we have with the units. 2 hours and 30 minutes. I have 2 different measures of time right now, so I'm going to have to convert them to both first convert the hours to minutes and convert the minutes to hours and be fluent with both of those, because notice 120 is in minutes, 2 is in hours. So it's asking which of these equations would not work. So what I'm going to have to do is try both of them out with the hours and the minutes. You'll notice, and this is just a side note, choices 1 and 3 are recursive because there are 2 parts. Choices 2 and 4 are explicit because they only have 1 part of their equations. So I just need to see essentially which one does not work right here and go from there. So first thing I'm going to do is convert these. I could have 2 hours, and if I convert 30 minutes to hours, it's going to be 0.5 hours because 30 minutes is half of an hour. Also, using that same idea to use these measurements, 2 hours in minutes is 120 minutes, and then 30 minutes would just stay 30 minutes then. Okay, so when I go to check these out, the first equation says that the first term is 120. That makes sense because on the first day, it was 120 minutes. That means this also has to be in minutes, and it is, but now I need to read the rest of the equation. It's saying this right here is the previous term, and each time I find the next term, I would have to take the previous term and add 30 minutes. That's exactly what's happening here. I'm starting at 120. If I take the previous term and add 30 minutes, the second day would be 150 minutes, then 180 minutes, and so on. This one works, which means it is not my answer. Okay, the next thing I'm going to check is choice 2. Actually, I'm going to check 3 first, just so you can kind of go with the recursive still. Recursive is the same idea, but now it's using hours instead of minutes. So it's saying that we are starting at 2 hours, which made sense. I was starting at 2 hours, and then each time I try to find the next term, I am taking the previous term and adding a half hour. That's exactly what this situation is. The next one would be 2.5 hours, then 3, then 3.5, and so on. So since this one is also correct, it is not my answer. Now, with an explicit formula, the n is your placeholder. So if I plug in a 1 for n, I should get the amount of time for the first day. So for this one, when I plug in 1, I get 90 plus 30 times 1. 90 plus 30 is 120, and that is true. That's how much I had on the first day. Let's try out the next one. If I plug in 1 for this, where it's in hours, the first day in hours was 2 hours, so I should get 2 when I plug in 1 for the first term. So this is 2.5 plus 0.5 times 1. When I add those together, I get that on the first day, it was 3 hours. That is incorrect. This one is my answer. So again, it's just a matter of testing them all out, being familiar with explicit and recursive formulas, and kind of going from there. All right. Number 17, if f of x equals a to the x, where a is greater than 1, then the inverse of the function is. So we have to remember what inverse means. To find the inverse, you have to switch x and y, then solve for y. This one's a trickier one because it's an exponential function, but let's give it a try. This f of x just means y, so when I switch x and y, it's going to be x equals a to the y. Now, if I am solving this now for y is up in the exponent. Think to yourself, what do you have to use to solve for a variable in the exponent? You have a huge hint in all of your answers. I'm going to have to use logs. So when you use logs, you write the word log on both sides. So the left side is going to be the log of x. And when I take the log of the right side, it's going to be the log of a. But remember, your log rule tells you to take the exponent and move it to the front. So if I'm solving this for y, I have to get y by itself. Right now, y is being multiplied by the log of a. So I'm going to divide both sides by the log of a. So I get my final answer for the inverse using inverse notation is going to be log x over log a. And then we start to panic because that answer is not written. There's actually no fractions at all. This is the change of base log formula. I need to change this to be written as not a fraction. So it's going to be the log of x. And when you divide by the log of a, that's the change of base. So that is going to be your base. A goes here. So this and this are equivalent to each other. It's the log change of base formula, which we just need to know. So this is my answer, log base a of x, which is going to be choice 3. All right, moving on to the next page, number 18. Kelly Ann has $20,000 to invest. She puts half of the money in. Oh, I love this question. She puts half of the money into an account that grows at an annual rate of 0.9% compounded monthly. That's a formula. At the same time, she puts the other half of the money into an account that grows continuously at an annual rate of 0.8%. So usually we're just doing one or the other. This one has both compounded formulas, so I need to write both of them. Compounded monthly is this one, the one that's raised to the NT. The continuously is PERT. Remember, it's really stupid, but PERT is a brand of shampoo, and we wash our hair continuously, so hopefully that helps you remember the formula. But those are my two formulas. Now here's where it gets kind of tricky. I have $20,000 to invest. Half goes into the first one, and half goes into the other one. So P is my starting amount in both of these formulas. P is not going to be 20,000 because I'm only putting half in each of these. So this is going to be 10,000 for both of them because that's half of 20,000. Okay, times, this one's going to be 1 plus. Now for the compounded monthly formula, it is 0.9%. To turn 0.9% into a decimal and get rid of the percentage symbol, I'm going to have to move the decimal point left 2 spots. So when I scoot it over left 2, I get 0.009. Okay. Then over n, n is how often it's compounded. Since this one is compounded monthly, it's going to be a 12 because there are 12 months in a year. Okay. Now that is raised to the NT, n is still 12, and then t is just t years. It's not telling me a time to plug in, so I'm just going to leave that as t. Now for the next formula, I have 10,000. The e is going to come down, and the rate is different for the compounded continuously one. It says compounded continuously at 0.8%. If I have 0.8 and I move that decimal point left 2 spots, I'm at 0.008. And then same situation, it's not giving me the time, so I'm just going to bring down the t. Now here's the big idea. This was invested into one account. This was invested into another account at different compounded rates. However, the question is asking which function represents the value of the investments, both of them, after the amount of time. So I would take the value of the first one, the value of the second one, and then to find my total amount of value in the investments, I would have to add them together. So you look through your choices, and the one that says that is choice, almost choice 4. Oopsie, sorry, I looked ahead. If you look at all of your choices, none of them have this as a fraction in here. So what you have to do is then simplify that in your calculator. So you are not plugging in this entire thing. We just have to simplify the part that's inside of the parentheses because none of them look like mine does with the 1 plus 0.009 over 12. So I'm going to plug that in, 1 plus 0.009 divided by 12. And I get 10,000 times 1.00075 to the 12t plus, that'll stay 10,000 e to the 0.008t. And now we can see that the answer is choice 4 because this number matches up with this decimal. And all the other numbers were correct. All right, number 19. Which graph represents a polynomial function that contains x squared plus 2x plus 1 as a factor? So what we need to remember about this is when you have something factored and you tee it up, you get the solutions, and those solutions are roots. So what I need to do first with this is actually factor it. I know it says which one has this as a factor, but it's not factored completely, and that's something that I'm going to have to do to get my answers. So this one is an easy trinomial. I need the two numbers that multiply to 1, that add to 2. It's just going to be 1 and 1. So when I factor this, I end up with x plus 1, x plus 1. When I tee this up and set these equal to 0, I have both the same factors equal to 0, and when I solve them, I get -1 on both sides. This is a prime example of a double root because I had two factors, but I ended up getting the same answer. So there's only one root that comes from this. It does not mean there's only one root. But because it came from two factors, it's going to be called a double root. So we need to remember what a double root looks like. A double root, when it crosses the x-axis, since this one's at -1, I'm going to put a point there, is going to be the vertex. So it could look like this, or it could look like this. It's just when the turning point hits. So a double root is going to look like this. And it has to be through -1. So I see all 4 graphs. I have a -1 here, -1 here, -1 here, and -1 here. When you look at all of them, they all cross -1, which is good, but there's only one that has a double root at -1, and it's choice 1. This one's not a double root. It goes straight through it. This one, same thing, goes straight through it, and so does this one. So all of these were out. They don't count as double roots. The only one that had a double root is 1. Now, like I said, that does not mean that -1 is the only root, because it's just saying that this is one of the factors. There's another factor for this one. Since it goes through 2, the other factor would be x minus 2. It just doesn't tell you anything about that. All that mattered to you was that you had a double root at -1, and that's what you were looking for. All right, number 20. Sodium iodine 131, used to treat certain medical conditions, has a half-life of 1.8 hours. The data table below shows the amount of sodium iodine. I don't know if I'm saying that right. Iodide. I don't know what I said the first time. Iodide. 131 doesn't really matter. Rounded to the nearest thousandth as the dose fades over time. What approximate amount of sodium will remain in the body after 18 hours? So, because these are half-lives, you have to be very careful. There's a couple different ways that we can do this, and I am going to show you both ways. Yeah, I'll show you both ways. The longer way is to continue on with your half-lives. So in 18 hours, when each half-life takes 1.8 hours, you would have to figure out how many half-lives are happening here. So I would take the amount of time that I have, which is 18 total hours, and divide it by the amount of time that one half-life takes to find out how many total half-lives that would be happening. It's going to be 10 half-lives. So what's happening here, and you can even double check your math, to get from here to here, it is dividing by 2 because we're taking the half-life. Another half-life happens, divide by 2, divide by 2, divide by 2. So again, this is the longer way to do it. This would be 6, 7, 8, 9, 10. You can just divide by 2 until you get to that 10th. Keep your work organized so you don't actually go to the 11th or the 9th, but that is one way to do it. What I highly recommend instead is, as soon as you see that word half-life, do the half-life formula. So that, I just wanted to show you that way first, because if you're in a pinch and you forgot the half-life formula, there are other ways to do these. The half-life formula is the easiest way to do this one. So I'm going to write out my half-life formula. It is A equals P times 1/2 to the T over half-life. Where T stands for time. A half-life is actually the half-life, which is 1.8 hours. And then there was a really, really tricky part of this. So for now, I'm just going to leave the A because that's what I'm trying to find, how much there is after 18 hours. P is the starting amount, which we're going to skip for a second. I'm going to put the 1/2 there because it's always 1/2 for half-life. My time is 18 hours and the half-life is 1.8. So this is where we got that 10 before. You could just plug in a 10 up there since we already did that math, but I'm just going to plug into the formula. Half-life was set in the directions to be 1.8 hours, and the time is 18 hours from here. Now here's why this one's tricky, and you better believe the answer's there for making this little mistake. A lot of people said that this was the starting amount. That is not the starting amount. That is how much is left after one half-life has already happened. The starting amount is when you have not yet occurred, or since, sorry. The starting amount is when a half-life has not happened yet, so 0 half-lives have gone by. So because this pattern going this way is dividing by 2, what I can do to come up with the amount at 0 half-lives is go the other way and multiply that by 2. That will get me my P, which is the starting amount at 0 half-lives. So 139 times 2 is 278. That's going to be my starting amount. So when you plug that into your calculator, remember, you either put parentheses around your exponent or just simplify it first. The way we've been doing it all year is simplifying it down to one number. That I think is easiest. But then you can just plug in the whole thing left to right as you see it, as long as you plug it in with the 10, and you will end up getting 0.271484375. Which is choice 3. If you plugged in 139 right here, you ended up getting one of the other answers. It was this one. And you feel so confident because you plugged in everything, and it just is not right. Be as careful as you possibly can. Of course, they're going to throw little tricks like that, and you're going to want to just plug in the number that you see, but 1 half-life is not the starting amount. You have to go back to that 0. Okay, only a few more left. This one's not so bad either. Which expressions are equivalent to blah? Right here, this little extra bit of information is an excluded value. It's just stating that x can't be 0 because if x was 0, you would have 2 times 0 on the bottom, which would be 0, and you're not allowed to have a 0 on the bottom. So really, it's just extra info telling you what would make this undefined. It doesn't apply to the question at all. It's just to correctly state that expression. Now, when something says equivalent to, it's not necessarily telling you what to do. You just have to kind of do some math to see what you get for your answers. So what I noticed right here is this is one fraction. To simplify a fraction, when you have polynomials, either top, bottom, or both, is you have to factor and cancel. On top, I have a GCF, so I'm going to take that GCF out. It will leave me with an x minus 4, and that'll be over 2x. Now, I factored. Now I'm got to cancel. I'm going to cancel this x with this x, and that'll leave me with x minus 4 over 2. So I know that this is equivalent to this. So this one's good to go. 2 has to be in my answer, and if you look, all of them have 2 in the answer, which is kind of a bummer. I can't eliminate anything yet. Now, that does not mean that it is only the second one. You have to see if any of these mathematically simplify to get these other choices. So when I have 2 terms on top being divided by 2, I'm going to divide them both by that 2. So this will be x over 2 because I can't actually divide those. And then when I do the negative 4 divided by 2, I get a 2. X over 2 minus 2 is this one right here, so that means that choice 1 is also correct. The only one I can eliminate right now, no, actually I can eliminate a couple. I can eliminate choice 1 because it says it's 2 only, and I know that 1 is also correct. And I can eliminate this one because it doesn't say that 1 is correct. So now I'm between choices 2 and 4. Wow. Oh, I remember now. So this one, you can't really look at this and try to simplify to that because that one's a little bit longer than this one. This one's more complicated. So what I'm going to do is simplify this and see if it ends up equaling what I have as my fully simplified. So I'm going to say that again just to make sure it kind of makes sense. This is simplified and this is simplified. There's only a couple of terms. They're small. This has a lot more going on. So what I'm going to do is simplify that to see if it matches one of my simplified answers. So I have x minus 1 over 2 minus 3 over 2. When you are subtracting or adding fractions together, you need common denominators. Lucky for us, we already have the common denominator of 2, so I'm just going to bring that 2 down. And then once you bring down the common denominator, you just simplify everything else by putting it together. So this is x minus 1 minus 3. When I combine like terms on top, I get x minus 4 over 2, and guess what? That's equal to this. That means that choice 3 is correct also, and it's going to be 1, 2, and 3, which is choice 4. All of them were correct. Little shortcut chat. Remember, anytime you have an equivalent to situation, what you can do is either graph them and see if their graphs compare, or you can plug in a number. I could have plugged in, like, for example, x equals 2. If I plugged in 2 right here, here, and here, I would have gotten a number. If I plug in 2 right here, if I plug in 2 right here, and if I plug in 2 right here, I'll end up getting those same exact values, which means that they're all equivalent functions. So we're going to do that shortcut day. We'll talk about it a little bit more then, but you want to just be mindful that these shortcuts can be done if you're ever in a pinch, or even just to check your answers. You guys have a lot of time to work on these exams, so it is definitely worth it to use your resources whenever you can. Okay, last page for this video, question 22. Consider blah and p of x defined by the graph below. So f of x is given as an equation, p of x is given by this graph. The difference between the values of the maximum of p and minimum of f is. So first we need to remember that difference means I have to subtract. So I'm subtracting the max of p minus the min of f. This is a little bit trickier. So the maximum of p, very easy to find. You need to know what a maximum is. Maximum is the highest point on a graph. So this is my maximum, which is at a value of 5. So that one was not so bad. It's 5 minus. Now I have to find the minimum of f of x. That means f of x is going to be a positive parabola, and the minimum is going to be my vertex, or the lowest turning point. So to find that, I'm going to have to look at the graph of it. So I go to my y equals, and I type that in, so I cleared this out, 4x squared plus 6x minus 3. And I'm going to look at the graph of it. I'm going to fix my window. There we go. Remember, Zoom 6 will always take you back to that 10 by 10. Okay, so now that I am looking at my graph, you can't just eyeball the minimum. You also, for this one, can't do it on the table because there is no pattern that shows you the minimum. Remember, sometimes on a parabola you'll have, like, I'm just making up numbers here. 1, 2, 2, 3. These match, which means that this is the vertex. I don't have that pattern on the table. That's what I'm trying to show you. So if that pattern's not there and you can't eyeball it on the graph, what you're going to have to do is second trace. So I'm trying to find a minimum. I'm going to go down to minimum, press enter. Now it will ask you questions. Your questions will be on the bottom of your calculator screen, but you just have to follow the examples that the questions that the calculator is asking you. When it says left bound, that means you have to move your cursor a little bit to the left of the minimum. So this is left of the minimum, I press enter. Then it says right bound. That means you now move your cursor to the right of the minimum, press enter, and then press enter one more time, and it'll estimate your minimum for you. It's telling me that the minimum is negative. Minimum is negative 0.75, comma, negative 5.25. If you envision plotting that, that means you would go left negative 0.75 and down negative 5.25. What I care about is the y value, which is negative 5.25. So that's the minimum of f. That's going to go right here. It's a negative 5.25. So now when I look at this, I have minus a negative, which is going to become a positive, and 5 plus 5.25 is 10.25, so choice 4. All right, number 23, the scores on a mathematics college entry exam are normally distributed. Those are keywords right there, with a mean of 68 and a standard deviation of 7.2. Students scoring higher than one standard deviation above the mean will not be enrolled in mathematics tutoring programs. So if they score more than one standard deviation above the mean, they will not be enrolled in the mathematics tutoring program. Oh, there's a lot in this question. How many of the 750 incoming students can be expected to be enrolled in the tutoring program? Okay, be not. So for this one, kind of a little bit tricky. It's not asking me for above and below a certain value. It's saying it has to be higher than one standard deviation above the mean. So we are going to be using normal CDF for this. When I go to do that, that means I need my lower, then my upper, then my mean, then my standard deviation. I have the mean is 68. I know that the standard deviation is 7.2. However, when I go to figure out the lower and upper, we're talking about being like higher than one standard deviation above. It's not giving me a numerical value. We have to figure out that numerical value. So this one is a little bit trickier. What I'm going to do to figure that out is draw my bell curve and actually do the math to figure it out. So the mean has to go in the middle, and the mean is 68. If we're talking about the scores being higher than one standard deviation above the mean, that means I need to go one standard deviation this way, and standard deviation is 7.2. So to get from here to here, I have to add 7.2. When I add 7.2 to that, I end up getting a value here of 75.2. So this ends up being my first standard deviation. Here's where this one gets a little bit tricky. Students scoring higher than one standard deviation above the mean will not be enrolled in the mathematics tutoring program. So that means what's highlighted in yellow right now will not be enrolled. However, it's asking me how many of the 750 incoming students can be expected to be enrolled. So it's asking me for the rest. Who would be enrolled would be everyone else. These ones are enrolled. So think about your lower and your upper. If I want the part that's shaded in the blue, I want from 75.2 and lower. So if we're going lower forever, that's going to be my negative 99999, just a really, really small number. And my upper is going to be the 75.2. So to get to that in my calculator, I press second vars. Vars is right next to clear. Remember, we never use normal PDF. It's going to be normal CDF every time, C for cool. My lower is negative 9999999, comma, my upper is 75.2, comma, my average is 68, and the standard deviation is 7.2. When I press enter, I get 0.8413447461. Great. Then I look at my choices and that answer is not there. Don't panic. We're not done. This means that about 84% of the students would be enrolled in the tutoring program, but it's asking me how many of the 750 students. If it's going to be about 84% of the 750 students, I now just need to take about 84% of 750 by multiplying my whole decimal by 750. So I just leave that decimal in there and multiply it by 750, and I get 631.00859955, blah, blah, blah. And that is choice 1. That's how many students are going to fall in that blue shaded interval. All right, number 24. How many solutions exist for 1 over 1 minus x squared equals blah, 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 blah. So if you look at that and try to solve it, it is going to be a nightmare. I have an x in the denominator over here. I have an absolute value here. We've never solved anything like that. So what you want to be thinking instead is how you can do this graphically. If I graph this in my y1 and I graph this side in my y2, I'm trying to see not where they're equal, but how many times those two equations are equal to each other. So really all I'm trying to do is see how many intersection points they have on the graph. So when I plug this in, it is going to be 1, let me do my fraction, 1 divided by 1 minus x squared. And the second one is going to be negative. To get the absolute value, I press second 0. And yours will be right at the top. I do not, oh, there it is. Mine is way down. It's ABS. So press enter for ABS. Hello, calculator. Okay, I'm going to get to it the other way. It is in math over to num, and it is the first choice. So 3x minus 2 goes inside. And on the outside is plus 5. If you have the 83 calculator, it'll say ABS, and it'll give you open parentheses. You do 3x minus 2, and then you have to close your parentheses, then type in the plus 5. Make sure you put that negative out in front as well. So this is for the 83 calc. Also, when you're plugging in that first one, if you have the 84 calc, you want to hit alpha y equals enter to plug it in as a fraction instead. If you don't, you have to put parentheses around both fractions. So the whole thing is a fraction, and you have to put parentheses around your denominator to show that that is in the entire denominator. So I'm going to press graph, and this is kind of a wild graph, but the whole idea here isn't even to find the intersection points. I don't care what values they intersect at. It is asking me how many solutions they have. So on this graph, I'm just going to sketch it really quick so I can actually draw on it because I can't draw on my calculator. This is, ooh, that was terrible. That was not my best work. Again, really good sketch here. It goes up like that and comes back down. So to find how many times they intersect, I really just need to count the intersection points. It intersects here, 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 and here. 4 intersection points, so my answer is going to be 4. And that's it. So that one's not too bad. You just needed to not try and tackle it algebraically because it is a nightmare. You want to plug it into your calculator and just see how many times they are equal to each other, or in other words, how many times they intersect.